Have you ever looked up at the sky and wondered why sometimes it sprinkles and other times it snows, even when the clouds look similar? It is a fascinating question that reveals the intricate dance of physics high above us. The primary difference in the microphysical processes that create rain versus snow lies in the temperature profile of the atmosphere from the cloud base down to the ground. Snow forms when temperatures remains at or below freezing throughout the entire column of air, allowing ice crystals to grow and reach the surface. Rain, on the other hand, typically involves a melting phase, where ice crystals or snowflakes fall through a layer of air that is above freezing. At its core, the formation of snow in cold clouds relies on a process called the Bergeron-Feindeisen process. In clouds containing both supercooled water droplets, which are liquid water below 0 degrees Celsius, and ice crystals, the ice crystals grow rapidly at the expense of the water droplets. This happens because the saturation vapor pressure over ice is lower than over supercooled water, causing water vapor to move from the droplets to the ice crystals, freezing onto them. As these ice crystals grow, they collide and stick together in a process known as aggregation, forming snowflakes. For rain to occur, these atmospheric dynamics shift. In warmer clouds, where temperatures are above freezing throughout, rain forms primarily through the collision coalescence process. Here, larger cloud droplets fall and collide with smaller droplets, accumulating them and growing in size until they are heavy enough to fall as raindrops. In clouds that start cold but have a warm layer closer to the ground, snowflakes form through the Bergeron-Feindeisen process aloft, but then they melt as they descend through the warmer air, turning into rain before reaching the surface. Understanding these processes involves appreciating specific terms that offer deeper insight. Supercooled water is crucial for snow formation, as it provides the vapor for ice crystal growth. The tiny particles around which ice crystals form are known as ice nuclei. Different crystal habits like dendrites, columns, or plates emerge depending on temperature and humidity conditions. Another term, riming, describes when supercooled water droplets freeze onto an ice crystal, adding mass and often obscuring the crystal's original shape. These intricate microphysical processes, from the growth of a single ice crystal to the melting of a snowflake, highlight how subtle variations in atmospheric temperature dictate whether we experience the gentle fall of snow or the refreshing patter of rain. Knowing these mechanisms helps us better predict precipitation types and appreciate the delicate balance of our planet's water cycle.
If you love learning about water, like, subscribe, and keep exploring with us.